Hey everyone, how are you today? It's Mr. Maloney here, ready to teach you guys all about biology. And before we really start talking about biology, we got to talk about some very simple stuff that you've probably learned about before, but I want to make sure we review it just so we're all on the same page. First thing we're going to talk about today is what is science and the idea of different things that are truly sciences versus fake science, especially kind of really important right now with all the news you hear about, fake news and fake science and stuff like that. I want you guys to be able to start to pick things out on your own. And then to the rest of the lesson today, which is going to be a short one, we're going to talk about the scientific method. So we're going to kind of quickly go through some things. So without further ado, let me get started. All right. So what is science? Well, science is actually just a logical or natural way of thinking. All right. What we do is we learn how nature works by observing. And you follow this very logical series of steps, which we call the scientific method, to draw conclusions about the physical world and to understand through different types of research and experimentation how things work. So that's really what we're doing. We're trying to figure out how things work. And the way we try to figure out how things work is by learning what actually causes those things to behave the way they do. If we're talking about biology, which we're going to get into in a couple lessons, biology is really just the study of life. So we're really studying how living things work and how they kind of originate the way they are. So it's really important for us to understand that. And then the big thing that we understand with science is that you can repeat all of these experiments, you can draw the same conclusions as long as you have a valid experiment. So a lot of times you'll hear about all these claims, or if you're on social media, whether it be, you know, the Snapchat or Instagram or Facebook, if some of you still use Facebook. I know a lot of you have probably left Facebook because your parents are on there and your grandparents are on there, but you'll see a lot of videos all over the place of different things and people claiming different things. And there's no police of what gets posted on social media. So there's a lot of stuff that's just wrong. And, people believe it because they saw it in a video. And well, that's something that we really want to be able to start being critical of. Start really kind of looking at that stuff and be like, does this make sense? I don't think so. It's kind of like a magician pulling, tricking you into thinking you pull a penny out from behind your ears or something like that. So, what is science and what is non-science? Well, the good thing in the science department in Chamonix High School, we teach you real science. Yeah, you guys, most of you took integrated science last year, where you learned a lot about chemistry and physics. This year, you're going to learn biology, and then you have the opportunity for chemistry next year, or physics the following year after that. You could also take earth and space science, environmental science. All of these are true sciences. We study, we have a logical series of approach to it. You can experiment, you can draw conclusions, and then you could write up your experiment, ship it around the world. And if they followed the exact same steps that you followed, they would get the exact same conclusion you got. So it's really important to understand that science is a repeatable process, and we make sure that we follow along as we go along. And if you follow a very specific set of steps, or you follow and address all those little details over time, you'll be fine. What are some things that aren't science? What are some things that are just kind of not true? Well, art and astrology. Astrology is reading of your horoscopes. Don't confuse astrology with astronomy, which is the study of the stars and the planets and the celestial bodies and how they move through the solar system and the universe. But astrology is like, oh, I'm a Pisces. I behave this way at a different time of year. No, that's not actually real. It's all made up. All those horoscopes are all made up. Yeah, they sound like they could belong to you, but that's like how most things work. Philosophy and the study of the way people think. Religion, unfortunately, is not a proven science. If this is up for debate, that's fine, but from a scientific method standpoint, religion is not a true science. And then you get extrasensory perception, like ESP, mind reading capabilities. Those are not true sciences, they're pseudoscience. So we use the word pseudo. Pseudo just means fake. So it's a kind of like a fake science. So other types like the idea of witchcraft or wizardry, all that sort of stuff. That's all fake. It's all made up. Now, are there parts of it that maybe are slightly believable? Absolutely. That's why people believe it. If there weren't parts that were believable, people would just ignore it and not believe any of it. But since parts of it's like, oh, maybe that's true, it's something that that's why things stay around and keep around in our society. All right, let's focus in on the scientific method, this logical series of steps. Now, here's what I want you to understand: that the scientific method is not just point A to point B. There's actually a continuum, because you can go through the scientific method, and the thing is, at the end, can you draw a conclusion that is wrong? Yeah, or disproves your observation? Absolutely. That's the best part about science, is that it is fluid, it is dynamic, it is constantly changing. And that's why people, so that's part of the reason why people discredit scientists, is because they look at this and they say, that doesn't make any sense. This isn't right. This is wrong. Yeah, it's wrong right now, but I just proved how it's wrong. Now I can take another attempt at proving how it's right. I think Thomas Edison, the inventor of the light bulb, upon inventing the light bulb, said, I didn't invent the light bulb. I found 20,000 ways not to build a light bulb, because it took him like somewhere in the range of 20,000 attempts to make an incandescent light bulb. So it's kind of crazy like that. But let's talk about the scientific method. All right. So the first step in the scientific method, let me see here, is to observe. So we're observing right now. The idea that you're going to see something. That's what a lot of you do. Any of you work on cars and you see or hear a problem, you want to figure that out. Or anyone that's ever seen anyone, if their parents are builders, or carpenters or plumbers or something like that, they find a problem and then they start to go quickly to figure out a solution. But they're actually going through the scientific method. Right? Step two is where you're going to come up with a plausible solution. You're making a guess at what could be the answer. And that's your hypothesis. That's the big word everyone always associates with the scientific method, is the idea of a hypothesis. Right? A hypothesis, a true, very good hypothesis, must fit two criteria. One, it is testable, meaning that you can design an experiment around it. If you cannot design an experiment around it, it's really not worth it. You can't say like behaviors aren't a good thing. So you can't say like, oh, if I, put a red light on a frog, they feel better, they feel happier. How do you measure how happy a frog feels? You can't. That's why it's not testable. Right? The other part about a hypothesis is that it must fit an if-then statement. If I do this, then this will happen. Right? If I replace the batteries, then the flashlight will work. If I connect a pipe to here, then it will drain this direction. If I put the board at this angle and put 4 nails in it, then it will hold up this structure. Stuff like that are testable hypotheses that are all designed around an observation that you had. So you got your hypothesis. Once you have your hypothesis and you know it's testable, you go and design your experiment. So what does your experiment look like? Well, you make up what it looks like. And when you're designing your experiment, which we're going to really focus in on tomorrow is all about designing a valid experiment, is identifying variables and controls. What are things that we're going to manipulate or change, and what are things that we are going to keep the same? And all of that, when the experiment starts to run, is so that you can collect and then analyze the data. So you're going to collect and analyze data based on that experimental design. If there's a flaw in your experimental design, you go back and you fix it. If your data doesn't prove what you wanted to prove, your hypothesis is just disproven. That's perfectly acceptable. You go back and you rework your hypothesis. It's not like I made a hypothesis, I'm a failure because it didn't work. No, it's not that situation. The last step is when your data aligns with your hypothesis and you observe your problem being fixed, or you observe something going on and you understand now why, you can draw your conclusion. So your conclusion, and again, your conclusion can be wrong. Your conclusion can be like, this doesn't work. That's a valid conclusion based on this. And you then just explain why. So you're going to get your data, you're going to then, so you observe, you come up with your hypothesis, that educated guess, that plausible solution. Then you're going to go and design your experiment, you collect your data, and you draw your conclusion about it. So here we have a little example here of someone trying to plant something. And so they have their soil, they have their plant, and they have their different seeds. And they're start asking, what type of fertilizer should I use? And now what you want to do is set up your experiment. And so what they're going to do is they have their hypothesis where they have, okay, I have these 3 fertilizers, and their hypothesis written here is not the best. Right? Plants will with fertilizer A will grow the fastest. That's not the best hypothesis. Let's put into an if-then statement. If I give these 3 fertilizers to the plants, then I believe the plant that gets fertilizer A will grow the fastest. Now, all of a sudden, it's a valid hypothesis, a very testable hypothesis. You design your experiment, and in this situation, they put 3 different plants in 3 different pots with the same soil, and they put different fertilizer in there to see how it grows. And in this situation, it looks like plant A is showing the best results, and then they drew their conclusion. My hypothesis was proven correct, or the idea that fertilizer A is the best for fertilizing and growing these plants. That's it. That's a scientific method in a nutshell. All right. I don't want to bore you down, make you sit here any longer and listen to me talk. I just wanted to make sure you understood what is science and what is a scientific method. So at the end of this, do you understand what the difference between science and fake science or pseudoscience is? The idea that, if you don't follow a logical series of steps and really design valid experiments, it's not really true science. Do you know what the scientific method is? Do you understand the steps in the scientific method? If you do, fantastic. You're in great shape. And if you don't, feel free to drop into an office hour or send me an email, send Mrs. Chenard an email, and we'll make sure we get to address your problem. Thank you so much, guys, for tuning in, and I look forward to seeing you the next lesson, or maybe even in person.